So I guess while you guys are all setting that up, I can just go through my intro slides. So you've selected Introduction to Data Analysis using Pandas. So thank you for joining me today. My name is Stefanie Molin. So a little bit about me. I'm a software engineer and data scientist at Bloomberg, and I work in New York City in information security. I'm also the author of Hands-on Data Analysis with Pandas, which is currently in its second edition. I do have some copies to give away during the session. So ask questions, be active. I did my undergrad in operations research at Columbia University, and I'm currently doing a master's in computer science with the ML specialization at Georgia Tech. So for the prerequisites, this is what we're all getting set up with now. So the README has the instructions on the environment setup if you want to do it locally, and this binder link here is the other option. So I guess I could just show what that looks like. If you click the binder link, it's going to load this for you pre-configured. And when it's set up, it will drop you in a Jupyter Lab environment with everything accessible. Just make sure that you are not inactive for too long or you will lose your session. But you can download things from here if you want to then save it. So just stay active and you can then access everything. It might take a while. It just depends on. So here you go. It's loading up the workshop. So let's say you would work in this notebooks folder. That's where everything is you're gonna work with. So if you would check the environment, you run this notebook here. But you'll notice that there's a download button up here, which you can use to save anything you're working in. Likewise, all these buttons here will be helpful. So let's see how's everyone doing with the setup. Just going to share the README link again. People who are late. Link to the binder. So if you just go to the link to that I just sent and click that binder badge, you'll have that link. So for reference, right here, click this binder link. Down here it says launch binder on the README. That's where you can access it. It's a very long link, so easier to click from there. Okay, so I guess we'll dive in now while everyone can, I guess, access the binder if you weren't able to set up so far. It'll be the best bet. Okay, so our session today, we have 4 sections, time permitting. So we will start with a brief introduction to pandas and the data structures that we're going to need to be aware of. This will be very helpful if you come from another language or you're just entirely new to pandas. So we're going to spend probably about a half hour or so on that section. And then the second section is the meat of this workshop. So it's going to be on data wrangling. That's going to be about an hour and a half over there. And we're going to cover a wide range of concepts. That's where we're going to see the strengths of pandas. And the third section, we're going to cover a little bit on data visualization. I do have resources as well for further avenues of exploration after we cover the basics there. That's going to be probably another half hour or so. And then finally, we'll have a hands-on data analysis lab where I'll leave you guys to try out some questions on your own, and I'll be here for help. We're going to work with a data set that we haven't touched so far in the training. So without further ado, let me just make sure there are no questions. Okay, we can get started. So as I mentioned before, follow along with those notebooks that are in the notebooks folder. This is going to make sure that when we have exercises at the end of each of those sections, that you're not seeing the answers before you actually try to do them yourself. So you get the chance to try. Okay, so we're going to get started with the basics of pandas. We're going to learn about series, data frame, and index classes. These are those basic building blocks, and it's important to understand how to work with them. So by the end of this section, you'll be able to create data frames and perform operations on them. You'll be able to inspect and filter your data, and then we're just going to build on all of these skills throughout the training. So to start off, we're going to look at the anatomy of a data frame. So first of all, what is a data frame? And I apologize, I realized yesterday you may not be able to see my mouse, so I'll try to highlight things. So a data frame is composed of one or more series. So this whole thing down here is a data frame. A series is a column. The series have names that are in bold up here, and those are themselves stored as a index, as well as these row labels down here, which are also an index. Traditionally, when we say the index, we're referring to the row labels down here, but it's an interesting thing to note that these columns, if you access the names of them, are also stored as an index. So we can extract any of these from that data frame. So here's an example of how we can extract the series for the name column. We just use .name, and we accessed it now off of that media rights data frame. So here's an example of what a series would look like. So we have a name, which is the name of the object. So in this case, it was the name of that column. The type is object because it's storing strings. It also has an index as well. The columns we access through the columns attribute. And again, this is what I was mentioning. This is actually an index. So these are just the names of all the columns. And the index for the row labels we access via index. In this case, our index is just numbers. It's just the row number, but we can do a lot more if we put information on the index, and we'll cover that in the next section. So here, just starting at 0, ending at 5 with a step of 1. All right, so now that we know what a data frame is, we can see how we can look into creating them. There's a wide variety of ways that you can do this, and I've linked to the page in the documentation that shows the list, basically. But obviously, we can't go into all of those. Some things to call out that you'd be interested in is creating it from Python objects, reading in flat files, web scraping, API requests. We're just going to go over a couple examples here, but definitely check out that page in the documentation for more. So to use a flat file, we import pandas as PD first, and then we use the pd.readcsv function, and we pass in the path to that file that we're going to read in. And we actually, most times, don't need to specify too many arguments. Pandas is smart enough to figure out what we want. This gives us our media rights data frame. This is the same data frame that we had in the previous slide, except this is the full file instead of just the first 5 rows. So another example that we can do is to collect from an API. So in this example, I'm collecting from NASA's Open Data portal using the Socrata Open Data API called SODA, which we'll see quite a bit in this session. So I'm using the requests library. So I import requests, then I'm using the get method, like HTTP get method to request this resource. And then I'm specifying some other parameters. This is just because the API is going to limit to 10,000. And if we put a limit higher than the rows that there are, we get the full data set back. So then we get our response. If the response is okay, we can extract the JSON response, that payload. And then we can actually pass this directly into pd.dataframe to generate a new data frame. So this is the same data set that the flat file was, but because it comes from the API, there's some differences in there. A couple of things to note is that we now have these 2 new columns, this one, and this geolocation is formatted differently. Now it's formatted as a dictionary. This is because it was coming from the JSON response, which understands how to work with dictionaries, whereas if you're saving a structure like that into a CSV, it's not going to be interpreted the same. Likewise, this year column is actually a proper date. Before, it was in some date format that was specified and then written into the CSV like that. So Pandas is able to understand this is a date without us doing anything, whereas the other version, we would have to tell it what format it's in. So sometimes you might want to collect data from different sources. That's basically the moral of the story here. So if you want to then save the data that you have into a CSV, you can just call the toCSV function or the method on that data frame. Here I'm just passing in the name of the file I want to save at, and that's where it would save this entire result. Okay, now we're going to move on to inspecting the data that's inside the data frame. So we have our data in there, we read it in, but we don't know how many columns, how many rows, what data types we're working at. And that's the first thing we'll want to do when we inspect the data. So we're going to work again with that media rights data set, which is the one that comes from that CSV flat file. So the first thing we might be interested to see are how many rows and columns are there. So to do that, we would access the shape attribute. And here we see that we have 45,716 meteorites, and we have 10 columns that describe those meteorites. We might want to see how many or what the column names are. Now that we know that there are 10 columns, what are they? So we saw it before, we can access the columns attribute, and we see that we have a variety here. So now that we know what the columns are, we would want to know what types of data each of those columns is currently holding. And to do that, we access the dtypes attribute. And so here we can see that the name is an object because it's a string, but something like the latitude and longitude are stored as floats. So one thing to note, as I was saying before, is that year is not being stored as a date time because Pandas didn't understand right away that that format was a date time. So it's being stored actually as a string. So next we might want to see what our data looks like. We saw this a couple times in the previous slides, but we weren't explicit about what it is. But if we call the head method, we'll see the first 5 rows by default. So here we can see, again, as I was saying, that location here is a tuple, whereas before it was a dictionary. And these are not being interpreted as date times by. So it's also very important, especially when you're reading from a file, to check the bottom to make sure that there is no extraneous data that's being read in and could actually be the reason why some of the data types are not what you expected them to be. So we just call the tail method, which acts just like head, but is looking from the bottom. So this is the first 5 or the bottom 5 rows off of the data frame. So nothing here is out of place. Next, we could also get information about the data frame by calling the info method. So this gives us a lot of things at once. We can see the type of index we have, which will come in handy in the next section. We can see how many rows. We can see the labels that the index has. We see that we have 10 columns. We see each column's name. We see how many non-null entries there are. So for example, there are some cases where we don't know the mass of the meteorite, and there are many cases where we don't know the location of the meteorite. We also see the data types and even information on memory usage. This will be important, especially if you do work in Binder frequently, you will run into that 2 GB limit. So, okay, so now we're going to look at extracting subsets from that data. So often we want to slice and dice data to look at things that meet certain criteria, or perhaps even by groups. So while we'll get to group by later, we need to be able to understand how to isolate areas of interest in the data frame. And that's what we're going to do in this section. So we saw before that we can extract columns by using them as attributes on the data frame. But what happens if the column has a space in it like this? So in that case, we can pass them in if we then pass it in as a list instead of doing here's where we have a list of 2, or we can use the brackets and just pass in that name. You can't access it as a dot with a space because that's not a valid Python variable. But this is also a good way if you want to reorder the columns. You can notice that these are selected or these are returned in the order that we select them. But this is the full data frame just for those 2 columns. So we can also select rows in a similar way using these square brackets. So here we're selecting the range of the rows from 100 to 104 exclusive. So it's very important if you're new to Python to remember that slicing operations are going to be exclusive of the end index. So we have 100, 101, 102, and 103. We do not have 104. Another way that we can do it, and the preferred way that you should be working with these kind of operations, is with ilock and lock. So these are indexing. So for example, ilock we would use to select by position. So I like to think of the I as integer for like the integer location, the row number. So here we're once again selecting 100 through 104, but now we're passing a list for the columns. We're picking the column at position 0, 3, 4, and 6, and then we get this result here. So first piece we have was the row indexer, then we have that comma, and then the column indexer. You don't have to provide, you can leave one of them out as well. We also have lock, which you can think of as label. I think the L for label. So in this case, we can still use 100 to 104. However, notice that we now have row 104, because now it's treating them as labels. And so it's almost like ignoring the fact that they're in a sequence, and it's going to pick everything that matches within there, inclusive. So now we get all of those. Those are technically the labels of these rows in the special case where they are numbers. So this will also work when these are named say with strings. And then we're also able to do this neat trick here, where we can select all of the columns from mass up to the year column and anything in between. And so now we get that fall column without having to explicitly name it. So another way of slicing and dicing the data is to use Boolean masks to filter. So a Boolean mask is an array-like structure of Boolean values. It's a way for us to indicate which rows or columns that we want to select by placing a true and which ones we don't by placing a false. So here's an example of one where we're creating a mask for meteorites that weigh more than 50 grams and that were found on Earth. So we have to create two Boolean masks first and then combine them together into a single mask. So the first mask, we take that mask column and we just check if it's greater than 50. So this is a vectorized operation. So we're actually getting back something of this exact same shape that's just true and false. And then we're combining it with another one that has true and false for whether or not it was the fall value was found. Then to combine the two of them, we surround them in parentheses and we use the bitwise and operator. And the reason we have to use bitwise and not the logical and is because that's what's being overridden to handle this kind of operation. So when we use this operation, it's going to go entry by entry and compare. So it's going to say, oh, okay, the meteorite is more than 50. So that's a true. Okay, what is meteorite? Oh, it was observed falling. Okay, false. So the whole thing is false. And then we get something back of this exact same shape. So just again, note the difference between those logical and bitwise operators. So here are the bitwise ones that you'll need. So we have and, we have or, and we have not. So we can also use this Boolean mask, and this is where it becomes tremendously helpful, is to actually select the data out of our data frame. So just by passing that mask that we created into these square brackets here, we're able to filter down that whole data set to just those meteorites that meet that criteria. So if you take a look at the mask, you'll see that they're all above that threshold and that they're always found. And these masks can also be used with lock and iLock. So an alternative to this is the query method. And there's some neat things here that we can do. First off is remember that the mask column has a space. So we have to surround it in backticks here. But we don't have to then say meteorites and then access the column because it's implicit here. So we can just say that this column is greater than 50. And now we can use logical and like we did before, or bitwise, either way, both will work in this case. So we pass in this to evaluate, and then we get the exact same result. Okay, so now we're going to move on to the last section of our Pandas intro here and calculate some summary statistics. So we're going to see this and build up on this a lot in the next section, but even without doing much data cleaning or data prep, you'll notice that we can always extract some interesting insights from this data set with summary statistics. For example, we can look at how many of the meteorites were found versus observed falling. So to do that, we just access that fall column and we can call value counts. So what value counts is going to do is going to look for each unique value in that column and then just count the number of occurrences. So we can see here that significantly many more were found versus observed falling. And we can also pass in normalize equals true to this when we call it, and that will return this result as percentages. So I've also linked to the documentation. You can read more about what this method can do. So next we might want to see, well, what is the mass of the average meteorite? So here we, if you recall, have to use the brackets because there's a space in this column name. But once we select that series, we can just call the median method. And we're using median because, as you will see, there are some significant outliers in this distribution. So if we then look at those quantiles to get a better feel for the distribution, we call the quantile method. Now here we have to specify what quantile we want to look at. In this case, we're passing in a list to see 4 different quantiles. So we want to see the first percentile, the 5th percentile, the 95th percentile, and the 99th percentile. And we get all of this information back here. You can see that just even going from the 95th to the 99th, there's a huge increase in mass. So then we might want to see, well, what's the difference between the 99th and then the largest meteorite? So what is the mass of the heaviest meteorite? So if we grab again that column and this time call max, you'll see that this is, again, much, much larger than even the 99th percentile. So then we can extract information on this particular meteorite. And to do that, we actually need, in this case, the index of the max. So if you're familiar with argmax, it's essentially the same thing, except we want the index label and not just the number. So we call IDX max. And so that will actually work in a case where our index isn't just numbers. So this gives us the row label of where this maximum weight meteorite occurred. And then we plug this in to lock, and we get the entire row where that happened. So here, this should look like a series, except now the name is actually that row number where this happened. So this is the name of the meteorite. That's that mass that we just saw. It was found in 1920 at this location. And fun fact, that is the meteorite down there. It landed in Namibia and it is currently a tourist attraction. So some other things we can do here are what types of meteorite classes are represented in this data set. So now we're dealing with columns that are categorical. So in this case, we take that class column, and then we can call n unique to count the number of unique values in that column. So there's 466. So obviously we don't want to print all of them, but we can take a look at what some of them are. And to do that, we just switch out n unique for unique, which is just going to find the unique values. And we're just looking at the first 20 here. So I've also linked if you want to read more about meteorite classes. So next we can combine some of these things. So we've been calling individual summary statistics on individual columns. So naturally there's going to be a way to do multiple summary statistics at once. So the describe method will describe all of your columns. Here it will focus either on numeric data or the categorical data unless you specify otherwise. Here we are specifying to include all. And so that means that we're summarizing both of our categorical and our numerical values. So looking at a categorical example, we have that rec class that we were just looking at. We can see that there were this many entries. We can see that 466 were unique, which matches what we just saw. We can see that the top or the mode is going to be L6, and that the frequency of that mode is 8,285. This also, you can take a look at the fall column and you will notice that those numbers there match up with what we saw with value counts. Finally, if you look at the a numerical column, say like the mass, you will now see that we have a 5-number summary here. So we have the minimum, the 25th percentile, the median, 75th percentile, and the max, and we also get the mean and the standard deviation. So we have all this information here. Anywhere where there's a mismatch, so saying have, in this case, categorical, what it considers a categorical statistic for a numeric column, you will get an NaN for not a number. This will be null values. So I've also linked here to the documentation for both series and data frames, so you can get a full listing of all the different types of descriptive statistics that you can calculate. Good idea to bookmark both of those for future reference. And up next, we're going to do data wrangling. But first, I want to give you guys a break to work on some exercises to practice what we have here. So I'll leave 10 minutes and let me know in the chat, I guess on Zoom and the other platform, if you are struggling or if you want a little bit more time. How's everyone doing on the questions? I put a poll in that WOVA thing, but I guess no one's using that. So if you let me know on the Zoom, if we're good to go over the solutions. Anybody? Okay. All right. We have one person. That's good. Okay. Good. Good enough. All right. So let's pick back up. We're going to go over these solutions before we move on to the second section. So for the first one, to create a data frame by reading in the 2019 yellow taxi trip data. So we import pandas as PD. We use the pd.readcsv function and we passed in that path. And this gave us our taxis data frame. So here's just a look at what it is by calling head. There's many rows, many columns. We are going to be working with this more in the rest of the workshop. This also comes from that SODA API, which is, you're able to get quite a bit of government data from there. So this is from New York City Open Data. So to find the dimensions, being the number of rows and the number of columns in the data, we use the shape attribute. So this is a 10,000 row sample of the full data set, and there's 18 columns. To calculate summary statistics for fair amount, tip amount, tolls amount, and total amount, you had to first select those columns, and then you can call describe. So here you can see that these are all numeric columns, so we get just the numeric summary statistics. And for the final one, to isolate the fare amount, tip amount, tolls amount, and total amount for the longest trip, we had to use some more complicated logic here. So first thing, we're concerned with those particular columns, so we use that in block. And we needed the longest trip distance. So we take that trip distance series and use the IDX max to get the index of the max. And then that's what gets passed into lock. And so here we get a series with the solution. All right, so section 1 is now complete, and we are ready to move on to data wrangling. So big part of what we would do when we were preparing data for analysis is going to be data wrangling. This is going to be things like cleaning data, reformatting it, say like renaming columns, fixing data type mismatches like we saw before, restructuring it, etc. So we're going to go through quite a bit of different examples here in this section. This is going to be the longest section of the day. So we're going to start out with data cleaning, and we're going to take a look at that yellow taxi trip data that we were just using in the exercises. So here we're reading it in again, and this is the data that we just saw. So we're going to start by dropping some columns. So there were many ID columns, but without the context of what those mean, these really aren't going to be helpful to us. So we want to drop those. And there's also that store and forward flag column, which we're not going to be using for this training. So we're going to drop that as well. So one way that we can drop these columns is to create a mask of the columns that we want to get rid of. And we do that by taking the columns, accessing the str for string functionality, and then we're going to use contains. This is going to give us a Boolean mask that is true when the column name matches this regular expression, which means either it ends in ID or it has store and forward flag. And we specify that this is a regular expression. So this gives us our mask, which then we can use plugging it back into the columns to pull out just the columns that we want to drop. So here you can see that those are the ones that match that criteria that we want to drop. So then to actually drop them, we can use the drop method on the data frame, and we pass this into columns so it knows which one, what we're referring to. This will then return our new data frame back, which we reassign in taxes. So here's a look at what it is now. You'll notice that those columns, some of those columns that were in the beginning that were IDs are gone, and there's fewer columns than we had before. So another way of doing this kind of operation is you can do the inverse. So instead of getting rid of what we don't want, you can select what we do want. And actually all you would need to do in this case is negate that Boolean mask, which will then have the true if you want to keep the column instead of getting rid of it. And you just pass that into lock. Here with lock, we're using the colon because we want all the rows in that case. So next up is we could rename columns. So you probably were wondering what that TPEP in the front of pickup date time and drop off date time meant. We don't need that, and it's just extra verbose, especially for typing. So we would want to rename those. We would call the rename method to do so. And in this case, we're going to pass to columns a dictionary that maps the old name to the new name, what we want to rename it to. So in this case, we're just renaming those two. And now we're going to add something new here, in place equals true. And this is going to update the data frame in place without us having to assign it back into taxis. Now, always be careful with in place operations. This one is fairly innocuous, but there may be some cases where you could end up doing something that is pretty impossible to undo without starting from scratch. So then if we look at our data now, we have pickup and drop off. So we're moving in the right direction. Next up is we might want to look at the type conversion. So if you notice, pickup and drop off are being stored as objects and not date times, which is not ideal. They certainly looked like date times, so we can address that next. So here we're selecting the drop off and the pickup times, and then we're going to apply to each of them. So on each column, call pd.toDateTime, and then store the result back in this selection. The reason you should use lock when you do editing parts like this of the data frame is there are potentially issues where you could be editing a view and not actually editing your data. So always use lock for this kind of operation. So now you'll notice that both pickup and drop off are stored as date times. And so now this actually opens up a bunch of functionality that we'll be able to do, and we will be exploring throughout this section. So other things to note of as far as type conversion, there's also an as type method, which you can call, so dot as type, and then you would pass in the type that you want to try to convert it to. That one is more of a low level one. As far as what you would try to do instead of that would be something like pd.toNumeric, which will try to convert it to either a float or an integer, depending on the data it sees. If it sees that there's any missing values, it's going to automatically convert them to floats instead of integers, because the integer column is not allowed to have null values. So rather than erroring out on you, it will handle that logic for you. So as far as the next steps would be creating some new columns. So we're going to create 4 new columns for each row. We want to create the one column for the elapsed time of the trip, another one for the tip percentage, a third for total taxes, tolls, fees, and surcharges, and a fourth for the average speed of the taxi. So we can do this all in a single method call with the assign method. So the first one here is this elapsed time. So the elapsed time, before the equal sign, we're going to name each of those arguments with the column that we want to create. You can update columns in the same way as well. So this doesn't have to be unique to the data frame name. But in this case, we're creating a new column called elapsed time. And then what it's equal to is what the data is going to evaluate to. So in this case, we're passing in a lambda function. And we're doing this for a couple of reasons. In this first case, the lambda is just easier than instead of having to type taxis.dropoff and taxis.pickup, we're just using this x because we're passing in this anonymous function here. So because our times are date times, we can actually do an operation like this and subtract them to get the elapsed time. So that's our first piece. Then for handling parts 2 and 3, we actually need an intermediary column. And that's what we're creating here, cost before tip. And once again, we're using a lambda. So this is the total amount minus the tip amount. And now we're going to see why we want to use lambdas, another reason. So when we get to the tip percentage, this is for the second question up here. So to do that, we actually need to access that cost before tip column that doesn't exist in taxis, but it does exist if we pass in the lambda, because at the point that the lambda gets evaluated, this x will be the data frame after running these two. So at that point, we have cost before tip. So then we can say that it should be the tip amount divided by the cost before tip. So now that gives us our tip percentage. For the fees, it's pretty similar. We use the lambda again. We want the cost before tip minus the fare amount. And then for the last one, the average speed, we take the trip distance, and then we're using the div method. You can also use this with plain division, but you will see that the div method comes particularly handy when you're chaining together operations, because it allows you to do it all in a single sequence of code, as well as control if you want to, instead of dividing everything in the column, you could divide across rows. You can control that axis that you work on. So here we're just dividing by the elapsed time, which we have to grab from up here, which is also why we need the lambda. Then we access dt to access the date time functionality. We get that time difference in total seconds, and then we're converting it to hours. This gives us miles per hour. So if we take a look at our data frame now, notice that we now have these new columns added to the right. So we have elapsed time, cost before tip, tip percentage, fees, and average speed. So we talked a little bit about why we would use the lambda functions. So one other thing to point out is if you just wanted to create a single new column, you could have just done with brackets like this. So now we're going to take a look at sorting. So you can use the sort values method to sort your data by multiple columns and multiple directions. So here's an example where we're sorting on passenger count in descending order, and then breaking ties by pickup time in ascending order. So the most that these taxis in the data set could fit was 6 people. So that's why all these have 6. And then we're breaking ties with the earliest pickup time, which is this one right here. So maybe you wanted to just get the largest 3 that had elapsed time, rather than sorting by elapsed time and then using head to get 3. you can just use n largest. So here we take our taxis data frame, call n largest, specify that we want 3, and that we should be using the elapsed time column. So if you take a look at these trips, you notice that maybe there's something a little strange in this data set. All of the trips that have the large elapsed time are nearly 24-hour trips. There's no tip, and it's probably the thing sitting in the lot, but who knows? Okay, now we're going to work on learning how to work with the index. Let me just check if there's, okay, just want to make sure there's no question because this is a long section, so it'll be hard for me otherwise to find what they were about. Okay, so far we've been haven't really done much with the index because we've been treating it more as a row number, but there's a lot more that we can do by pushing information into that index. So we're going to see that in this section. So to begin exploring this functionality, the first thing we need to do is to actually put some of that information in the index. So we can call the setIndex method, and we'll specify what we want to put in the index. In this case, we're going to put that pickup time. And we're again doing this in place. You don't have to. And now we have this column has moved off to the left. You'll notice that it's now in bold, and we no longer have those index numbers that we had before. So one thing we're going to do now is also sort the data using that index by calling sort index. So this time way we'll have the first entry will be the earliest pickup. So a neat thing to point out about sort index is that you can also use it to sort your columns by name. If you pass in axis equals 1 to target those instead of the rows. And that axis argument is something that you'll see a lot throughout Pandas. So now we can do something really neat with the selection of the rows is we can actually use date times to select them and to slice our data. So here's an example where we're slicing the taxis data set to find all the pickup times or all the pickups between October 23rd, 2019, 7:45 a.m. and through the 8 a.m. hour. So this is essentially pattern matching up to that point. So anything that's a wild card after that bit will be matched. So you see that we have 818, and that's the reason why. But we've sliced through all of that very, very easily with this syntax. So you can even specify just a range in this way, or say you just want the 8 a.m. hour. But in this case, you have to use lock. This is somewhat of a newer change to be aware of. So you have to use lock in this case. But here we get both of those pickups that happened in this time. So one thing we might want to do is also be able to reset our index. Some operations will push information into the index that you actually don't want there, or you want to pull it back in as a regular column. And in that case, you just call the reset index method. So we're going to see more of that stuff, the index now. That's just a bit of a primer. For now, we're going to move on to reshaping our data. And we're going to switch over to a new data set to really motivate why we want to do such a reshaping. So this is a new data set of TSA traveler throughput, and it's intended to compare the 2021 throughput to the same day in 2020 and 2019. So this was collected in May this year. So the first date you see here is as far back as it goes. I should say is the most recent date that we have. And you'll notice that the date here has 2021 in it, but then when you look at the column 2020, this has values. So this is actually, this highlighted value is what the number was on May 15th, 2020, which makes it very confusing to look at the way this is laid out. And one thing we would want to do in this case is be able to unravel this to have a single time series that just has date and number and be able to work with that. And so that's what we're gonna do here. I also want to point out that some other things that you can add when you read in a data frame or read in a CSV. Here I'm parsing the dates by just specifying that it's the date column I want to parse. There's a ton of functionality that you can access by passing in different parameters to this function. So I definitely encourage you read through this. A lot of times you'll end up reading in the data frame first, then figuring out what you have to do, but then next time you read it or other times that you're automating process, you'll then know what needs to be set in there to move some of that pre-processing into the read part of your code. So the first thing we're going to do here is just make the columns a little easier to work with. We're going to lowercase everything, and then we're going to remove that throughput where it says traveler throughput. It's just redundant. We don't need that everywhere. So we want it just to be the year. So to do that, we use the rename method again. Now we do it a little differently. If you recall from before, we passed in a dictionary that mapped the old name to the new name. Now we're passing in a lambda. So it's going to say, take the column name, call lower to lowercase it, and then split, which will split by default on a, which is exactly what we want. And then take the first word in that list. So that gives us the following result, where we now have date in lowercase, 2021, 2020, and 2019 as our columns. And we're going to be using these column names to update those dates. This is exactly what we need. And now we're going to work on reshaping this. So the first thing we need to do is to melt our data. This is going to help us convert it into a long format, as right now we have, we want to be able to get, like I said, that single column where we have all of the traveler information over time. So we take our TSA data frame. We're going to call the melt method. Then we specify with ID vars what column uniquely identifies the row, and that's going to be the date. Next, we have our var name and our value name. So the var name is going to be the name of the new column that's going to be created. That data is going to be the column names that we had before, which is going to be those years. So that's why we call it year. And then value name is going to be the name of the new column that gets created that has the values of the columns that we're smushing together into the thing. So we now have this travelers that has those numbers that were in there before, and the year, which has the column names from before. So we're storing this in TSA melted, and I'm just showing some random entries here. You can see that with this, this row highlighted here is the only row which is actually correctly matched. This number here is indeed the value on July 3rd, 2020, but say this value on the row above is actually the value on July 19th, 2019, not 2018, or sorry, not 2020. So we're gonna update that next. So to do that, we need to update the date that is in the date column by replacing the year there with the year that was in the year column. So to do that, we're going to call the assign method. And in this case, we're using assign to update a value. So we still call it date. We're going to pass in a lambda. And then we're going to, because this year column is actually a string because those were column names. Pandas is not going to try to convert everything when it's doing any operation. So it took in the column names that were strings and left them as strings. So in that case, we can use concatenation to build up a new datetime string and then convert it to a datetime to be a new date. So that's our year plus then the original date that was what we're fixing. So we took that date, we access DT to get datetime functionality on that series. We do string F for format time, and then we're specifying that we want to format all of those old dates as dash and then the month and then dash and then the day. And then this gives us just the piece without the year. So then when we concatenate this together, we have a full datetime string, and then we can pass this into pd.toDateTime. So now if we look at the result, you'll see that the year in the date column matches the year in the year column. So now these are actually all properly matched. But this leaves us with some null values. So if you sort by the date and say, look at the end, you'll see that we now have values because these dates will get created from that operation, but these were never, there's no data for them yet. These are still in the future, or they're beyond the scope of that data set. So we want to drop those null values. So that's what we'll do by calling drop NA. So by default, without changing any of the options, this is going to drop any rows with any null values. So this works for us here. And now if we did that same thing, sorting by the date and looking at the end, we now have the most recent date in our data is the end, and it has a value. So everything's good here. So next we're going to move on to pivoting. Make sure there's no questions. Yeah, so basically lower is just easier to type. You don't have to shift. Okay. So pivoting. So next thing we want to do is kind of harkening back to what was probably the original intention of that data set that was provided, is to be able to compare the same date across years. But it's easier to do in a pivot table format. So we're going to work on that next. So if we take our data, and now we're also going to see some of the power of using the query method for those that were doubting it before. You can call query, And we can actually run some more complicated operations inside the query. So here we're filtering down to month 3. So anything in March by doing date.dt.month. And then we're combining that with date.dt.day less than or equal to 10. So we're getting the first 10 days in March. Next, we're going to use the assign method to create a new column. And we need this new column for our pivot. This is just going to be the day in March. So it's going to be the date.dt.day. And finally, we call the pivot method. So we specify for our index that we want to have a row for each unique value of year. For our columns, we want a new column for each unique value of that day in March. So we're going to have 10. And then the values for each of that row column intersection should be coming from the travelers column. So this is our TSA pivot. And now we can see you can easily compare dates across the years. So say you wanted to look at, I don't know, the 5th of March, you can see that easily this is 2019 number, this is the 2020 number, and this was the 2021 number. Likewise, if you look at the 10th, you can easily see the drop off. So I want to also call out unstack and stack, which are also ways of pivoting and melting. We're not going to cover them in this training, but they will come especially in handy if you're working with multi-level indexes. So you could run set index on more than one column, which we also didn't cover, but that's a little bit more advanced, but definitely check both of those out. Next thing we want to look at is another way of reshaping our data. It's transposing. So it's just flipping the rows and the columns. And especially in this example, they can be very helpful when you want to make better use of your screen real estate. So in this case, the other example was running right to the edge. We just tack on the .t here, and now we flipped everything, and it's a little easier to see in this layout, but we can still compare the exact same information. So now we're going to take a look at merging to add additional context to our data. So one thing that is particularly relevant when you're looking at this kind of a data set for TSA traveler throughput is when are the holidays. So we're going to read in a new data set. This comes from holidays.csv. We're going to parse the dates, and we're going to set the index column to the date right off the bat. So if we just look here at the 2019 data, you see that we have these holidays. So we can merge this information with our TSA traveler throughput so that we have an additional column indicating whether it was a holiday or not. So we take our TSA melted data frame, we call the merge method, then we pass in the holidays data frame. Now, for those of you who are familiar with SQL, you can treat the data frame that we called merge on as the left data frame, and then the data frame we pass in as the right data frame. And that terminology will come in handy when you have the remaining arguments here. So how is we specify what kind of a join we want. In this case, we want a left join because there's going to be days that aren't holidays and we don't want to lose that information, but we want to keep all of the information from the TSA melted. So we have a left join. Our left on is these, and right index are going to be for our join on clause. So our left on is going to be using the date column from TSA melted. And then on our right side, we're going to use the right index of holidays. So that's what right index equals true. This illustration, this is done to illustrate that you can target the index and then also column. Obviously, you don't have to do it in this format. You can use any combination. So at that point, we have our data merged, and we're just going to sort by the date. So if we take a look now, you see that the first date we have here is New Year's Day 2019, but the day after it, we don't have a holiday, which is exactly what we were expecting. There are a lot of methods, a lot of parameters to merge, as I was mentioning before, so I've linked out to the documentation. But if you want to just append rows, and then I'd recommend taking a look at the append method or pd.concat, that function. So we can take this a step further because people may not necessarily be traveling just on the day of the holiday, but likely before and after for some period of time. So we can fill in some of those null values with that holiday to extend and have kind of a holiday time period around each of the holidays. So that's what we're going to do here. So we take our data that we just merged in, we call the assign method, and now we're going to update the holiday column. We're going to use a lambda again. We're going to pass in, we're going to access the holiday series. And now we're going to forward fill one day after the holiday. So we're going to take, in the case of we had New Year's Day, we're now going to fill in forward once. So we're going to fill in January 2nd with New Year's Day. And likewise, after that, we're going to do a backfill, but limit it to 2 this time backwards. So now, if you look, for example, at the result, this day down here is actually the real Thanksgiving, but we're filling in these first 2 days above it, the 26th and the 27th, to also say Thanksgiving, to account for that holiday travel that happens beforehand. So that's what that second call to fill in A does. So after we do that, we can then, here we're just querying, and you get another taste for how powerful query is. So here, remember that year is still a string. So we have to check that it's equal to the string of 2019. And then we have and we're taking a look at holiday as either Thanksgiving or it contains the word Christmas. And so here you can see, in the case of Christmas, we now have Christmas Eve 2 days before the actual Christmas Eve. And then Christmas Day is then forward filled 1 day beyond Christmas Day. So I've also linked to the documentation for fill NA, because as you could have guessed, there are also lots of additional parameters there to check out. Now we're going to take a look at aggregations and grouping. So after we've reshaped and cleaned our data, we often want to perform some aggregations to summarize it. And that's what we're going to do in this section. We're going to take a look in particular at pivot tables, crosstabs, and group by operations. So we're going to start with pivot tables. So these are a little different from pivot that we saw before. So the pivot method is just going to rearrange your data. The pivot table method will rearrange and then aggregate. So you have to keep track of the two of them, that they're a little different. So here we're going to use our holiday travel and summarize it by year and be able to compare across years. So to do that, we take our data frame, we call the pivot table method. For our index, we want unique values of year. For our columns, we want unique values of the holiday column. The values that we fill in are going to be the travelers, and we want to sum them so that they fit into those subsets. And we do that by specifying agfunc for aggregation function equals sum. It's defaulting to the mean, so just be careful with that. So here, if you take a look, given when the data was collected, the only holiday where we can compare across all 3 years is New Year's Day. And you will get nulls for anything that does not have any data. But you can already see the huge drop off, say if you looked at New Year's Eve from 2019 to 2020. So we can also use the PCT change method on that result that we just got to get an idea of the percent change. So simply tacking on PCT change at the end, this is going to do a row by row percent change. So we see that from 2019 to 2020, there was a 65% drop on Christmas Day travel. We all know why all this stuff, but just, quick, easy way to calculate these statistics. All right, so for our next example, we're going to work with some very large numbers. So we're going to set a display option for Pandas so that we don't get scientific notation for everything. So we do this by calling pd.set option. We're targeting a display option, and specifically the float format. And then we're passing in a format string, technically a format method. So this is going to be, if you're familiar with number formatting in Python, this works the exact same way. So after this colon, we have our format. So we want, with this part here, we want to format the floats with 0 digits of precision, so effectively making them integers, and that we want a comma for the thousands separator, just to make it easier to see the large numbers. Next thing we're going to do is group together Christmas Eve and Christmas Day, and then do the same thing for New Year's Eve and New Year's Day. And then we'll be able to create our pivot table. So to do the grouping, we're going to import NumPy as NP, and then we're going to take our data. We're going to call assign to update the holiday column, and we're going to use a lambda to update the holiday. And we're going to use the following rule. So using numpy.where, which is a vectorized if else. So where, this is our clause. So it says if the holiday contains Christmas or New Year with a regular expression, we are going to replace that word day or eve with an empty string. And then we are going to remove any white space by stripping it out. Otherwise, if it didn't contain Christmas or New Year's, we're just going to return the holiday. We're going to leave it alone. Next, we call pivot table, and then this part should look familiar to what we had before. We have the unique values of the year in the index, unique values of the holiday column in the columns. We are aggregating the sum of the travelers in each of the cells, and these next two lines are new. So the first one, margins equals true, tells Pandas that we want total columns, subtotals. So in this case, it gives us this new row along the bottom, which is going to be the column sum. And it also gives us this new column, which is going to be the row sum. And then, of course, the bottom rightmost cell will now be the total of everything. And this margins name, we're just renaming it. I believe the default is all. I'm renaming it to total. So now you can clearly see the numbers, and they're all formatted according to that format that we specified before. And it makes it very easy to compare these numbers across years and holidays. Okay, so before we move on, we're just going to undo that display option by resetting it. We just call pd.reset option and pass in what we targeted before. So there's a lot to read also on options if you're curious more about that. So I've linked to that in the documentation as well. So now we're going to take a look at crosstabs. And these provide, at least on the surface level, an easy way to create a frequency table, but there's a whole lot more that they could be used for. So first off, we're going to create a frequency table that's going to count how many low, medium, and high volume travel days we had per year. First thing we have to do is we have to learn a new Pandas function here. This is pd.cut. This is for binning our data. So it's going to bin the travelers column into 3 bins. Pandas is going to determine the ranges for us, but they are going to be equal width bins. So equal width meaning the bin range themselves will have equal width, not that the bins will have an equal amount of values. Then we pass in labels to label the bin names. So we want low, medium, and high. And then this will be our index. And for our columns, we're going to put the year. And notice that we're actually passing in entire series. So this is the same shape as the data, and this is also the same shape as the data. So these have to match in dimensions. And then finally, we're just specifying row names equals travel volume, and that ends up here, just so that it's a little clear what these are. Otherwise, it would have said travelers, and that's not necessarily what that column is anymore. So now we can easily see that when these bins are made on the full data set, that 2019 has no days that were considered low volume, but 2021 has none that were considered high volume. So pd.crosstab also supports other aggregations. If you pass in the values that you want to aggregate as the values argument, and you'll also have to specify the aggregation that you want to use with agfunc. So in that sense, it's a little similar to crosstab, but you'll notice that there's a bit more functionality that you can do in here that you couldn't do if you used the pivot table, things like normalizing the data. So I've linked to the documentation for more. So now we're going to take a look at group by operations. So rather than performing an aggregation across all of the data like we were doing in that first section where we called mean or describe, you can perform them on groups of the data. If you first call group by and pass in what you're grouping by. So here we have our data frame. We're grouping by the year column, and then we call describe. And now we get those same summary statistics we were looking at before, but broken down per year. So we can easily say compare the minimum travelers on any given day in 2019 to that of 2020 and 2021. So we can also do separate calculations on different members of the groups or different groups. So here's an example where we're looking at the highest volume travel day per year by using the rank method. So we're going to create with a sign the new column that we're going to work with using a lambda. So we take our data, X, we group by year, then we access the travelers column, which we're going to perform the aggregation on, and then we call rank. We're ranking in descending order because we want rank 1 to be the highest volume travel day. If we then sort this data by that rank, breaking ties with the year, we will then see for each year what was the highest volume travel rank day. So in 2019, this was the day after Thanksgiving, and the other days are not related to holidays. But in both of those previous 2 examples, we were calling a single method on that group's data. But if we want to call multiple ones, we can switch to using the ag method. And this will allow us to specify any number of aggregations we want to perform. So here we're still using a sign, And now we're going to create two new columns. One is going to be the holiday traveler count, and the other one is going to be the non-holiday traveler count. This way we'll be able to do some aggregations on those different subsets. So our holiday travelers, we're going to use numpy.where again. So wherever the holiday is not null, then we'll take the traveler count. Otherwise, we add a null. And likewise, the non-holiday travelers is just the inverse. So wherever the holiday is null, we take the traveler count. Otherwise, we put null. It's super important to put null there, because if you have any value that is not null, it will be included in the aggregation, and you will get results that don't quite match what the data actually is for that. So next, we group by the year once again, and then we call ag. This time we're passing in a list of different aggregations to perform. We're specifying mean and standard deviation. And then notice in the result that we actually have these aggregations for 3 columns. These are the 3 columns where mean and standard deviation can be run. These are the 3 numeric columns in the data. So this makes it very easy to compare, say what is the mean number of holiday travelers per year, and comparing that to non-holiday travelers on any given day. What do those means look like, standard deviations, etc. So we can also go a step further and be even more fine-tuned in how we specify aggregation. Maybe we actually were only concerned with the holiday travelers, and we also wanted some aggregation on the categorical data. You can do that as well by targeting things, passing in a dictionary to ag instead. So here, the keys are going to be the columns that we want to aggregate. So in this case, holiday travelers and holiday. And then the values are going to be what kind of aggregations you want to perform. So for holiday travelers, we wanted the mean and the standard deviation. And then for the holiday column, since that's categorical, we wanted the number of unique and then the count. And you can see that these are now the only 2 being aggregated, and they each have their corresponding aggregations. So we are obviously only scratching the surface of what is available with this kind of functionality as well. Some other things that are nice to be aware of is that you can group by multiple columns. That creates something that we were talking about before, is that hierarchical index, in which case things like stack and unstack will come into play again. Groups can be excluded from calculations if you use the filter method. So that's one thing to look up in the documentation. You can also group by stuff that is in your index if you have a level number for it or the name of it. So you'll have a name in the case where you either explicitly set a name, or if you set an index. We saw before that, like when we set the pickup column as the index, that would still have a name, and so you could access it like that. And finally, you can group by date ranges if you use a pd.grouper object. Another way of doing that is with resampling, which we're going to look at next. So I've also linked the documentation for more on all of this. And with that, we'll move on to time series. Let's see if there's any. I'll go through the questions when we finish this section when you guys are doing the exercises, because there's a lot. So we're going to look at time series functionality now. So Pandas has a lot of additional functionality that focuses on time series that makes it really powerful. It's very important to be able to understand or to analyze that relationship with things in time. And so it's very important to have this good grasp of this functionality. In particular, we're going to take a look at how we can select date and time ranges, calculate changes over time, perform window calculations, and then resample that data to different time intervals, like I was just alluding to. So we'll start off, we're going to move back to our taxis data set for a bit. If you recall, it had timestamps for pickups and drop-offs. So the first thing we're going to do here is we're going to set the drop-off time, just to change it up from before, as the index, and we're going to sort the index. So both of these operations should be familiar. And we saw earlier that we can do something like this to slice out the data. Recall that it is going to match everything up to here, and the rest will be a wildcard. So this is between the noon and the end of the 1 o'clock hour. And that we could also do something like this with lock if we just wanted a particular value. So here's anything at noon, in the noon hour. But if we wanted to look at something of this, say the same time range, but across days, we would need another strategy. So here I'm going to introduce the between time method. And this is going to give us, for this example, any drop-offs between noon and 1 on any day in the data set. So if you notice now, the first one is on the 23rd and the second one is on the 24th. Obviously, if there was more in this data set, not just the 10,000 rows, you would get a lot more variety as far as the dates. There's also the @time method, which can be used to extract all entries, say, at a given time. This is particularly useful if you're working with, say, stock market data, and you want to extract maybe everything at market close across an entire year. You could easily do that. Another neat thing about working with this kind of like a time data is you can use instead of being restricted to head and tail, we have access to the first and last methods. And that will allow us to grab any number of rows that matches that criteria. So in this case, we're grabbing the first 2 hours of drop-offs. So if you notice, the first one is at 7:52. So we have 9:49 is the last. So it's 2 hours of drop-offs that are in the data. All right, so now we're going to go back to the TSA traveler throughput because we no longer need that time piece, and we're just going to work with dates. But now we're going to set the index to the date column for the rest of the section. And now we're going to look at how we can calculate change over time. So we'll take our data frame and we're going to restrict it just to 2020, just so we have something a little more manageable. We're going to assign to create some new columns. We're going to create 2 of them. The first is going to be the 1-day change. So we take the travelers column and we call diff, and Pandas will automatically calculate the 1-day change just by calling diff. To get the 7-day change, we pass in 7 to diff. And so if we look at the result here, you see that on the first day of the data, because remember we restricted to 2020 before calling any of this, we have nothing for the 1-day change and nothing for the 7-day change. Then on the second, we now have a value, which is the difference between the first and the second, but we have nothing on the 7-day change. By the time we get to day 8, we can now look back at day 1 and we have 7 days. And so this is able to calculate. So another method to be aware of is the shift method. So if you wanted to perform some operation like this, but maybe you didn't want subtraction, or you wanted to say, look at the difference between different columns over time, and you can do that with the shift method. And now we're going to take a look at resampling. So we can use resampling to aggregate time series to a new frequency. So here we're going to aggregate the TSA data to quarterly levels and calculate some statistics. So first thing, because we're dealing with quarters, we want to make sure that all of our data is part of a complete quarter. We don't have a full quarter for Q2 2021, so we're ignoring it. So here's also a neat thing that you can do with the slicing. By just saying 2019, we're selecting all the 2019 data, and we're ending it through and including 2021 Q1. So this is also a valid format for this. Next, we call the resample method, and we're passing in a frequency of Q for quarter. And then we call the ag method. We're passing in that we want a sum, a mean, and a standard deviation. And so you can see now in the data that we now have the total travelers for each of the quarters, the mean on any given day in that quarter, and the standard deviation over time. Now, in order to figure out which frequencies are best, you can also consult the documentation for that. So now we're going to move on to window calculations. These are going to be very similar to the syntax that we saw with group bys and just also what we saw with resampling, except that what we're going to group over isn't necessarily going to be static. So in one case, we can have a moving window. We can also have an expanding window. So Pandas has a variety of functionality for different kinds of windows. We're here only going to look at rolling and expanding calculations here. So performing a window calculation, as I was saying, is very similar to a group by. We're first going to define the window, and then we simply specify the aggregation. So here's once again that 2020 subset of our traveler data. We're going to assign, and we're having a trick here, which we'll get to in a bit. But basically, we have our 7-day moving average, which is going to be taking our data frame, calling rolling, passing in 7D for 7 days, then accessing travelers, and then calling the mean. And then the year-to-date mean needs to be an expanding mean. So instead of calling rolling, we call expanding, but then the rest is the same. We call travelers and the mean. So now if you notice, these are being stored in a dictionary, and there's names. These names have spaces in them. So we're doing this for a couple of reasons, as you'll see on the next slide. But when we use these double stars here, this is going to pull out all of these values and pass it into a sign. So it will work with a sign, and we actually get spaces in these column names now, which is going to show up nice when we get to the next slide. So if we just take a look at the values, For the 7-day mean and the year-to-date mean, you'll notice that they are identical until we get to day 8, at which point the 7-day mean stops using the first, whereas the year-to-date mean still does. So to get a better idea of what these look like, we're going to get a sneak peek at plotting, which we're going to do in the next section. So here you can see that we're just using this matplotlib inline, which is an IPython magic to embed this plot. But our code this is what we had on the previous slide. And just to call plot, we just say .plot, pass in some configuration, and we get our output here. So notice that the orange line, I apologize if anyone's colorblind, the orange line is closely tracking the blue line, which is the travelers, but it's more smooth, right? And the year-to-date one is finding the central tendency over time. So it starts out close, and then it really doesn't follow that dip that happens when COVID hits. So it stays more in the middle. But you'll notice that these spaced and the names come in handy because now they're in the legend, and it looks a lot neater than if we had underscores, for example. So it's just a neat trick to be aware that that's possible. Okay, so there are other kinds of windows. I mentioned that there's also exponentially weighted moving windows, which I've linked to in the documentation there. You can also create your own if you want to do some subclassing. They also have some pre-built ones in Pandas API indexers. So definitely check out all those if you need to do anything more complicated. All right, so we're gonna take a 25-minute break for some more exercises. There's a lot more here, and I don't expect everyone to get through all of them in here. There's some that are meant to be some challenges for those that are more experienced in Pandas already. But I'll give you 25 minutes and we'll go over the solutions when we come back. All right, how's everyone doing on the exercises? Anyone want to put in the chat how they're doing? Slow? Yeah, they're meant to be more of a challenge for sure. But want to move on, guys. 1 to 3 is very good, very good. That's honestly where 4 can really trip you up, and then the last 3 are more the challenge ones. So feel very good for getting that far. So we're going to move on. So in the interest of time, and we're going to go over these. And we'll have a chance in the final section to practice with some more exercises. So don't worry about that. All right. So for the first one, reading in the meteorite data, that should have been fairly straightforward. We use PD to read CSV, and we pass in the path to the data. Now I saw someone that seemed to have an issue finding or having an issue reading in this file. Just make sure that you're working in the notebook that are provided. Otherwise, you might have a different working directory, in which case this path is not going to be the same path that you need. So for the second one, to rename that mass column to just saying mass, and then drop all the latitude and longitude columns. So the first piece to tackle is the renaming. So we use the rename method, and we pass to the columns argument a dictionary that we have the old mass name and then the new mass as the value. Next, we call the drop method, and we're passing to columns the columns that we want to drop. I'm using a trick here where it turns out in this particular data set that the last 3 columns are actually the ones we want to drop. So I take the columns and I index from the third to the last to the end, and then I am able to remove all those at once. So then looking at the data, we now have the renamed mass column, and we got rid of those other columns. So the next was to update the year column to only contain the year, and then create a new column indicating if the year is unknown. So we're going to use a sign for both of these. For the first piece, we need to update the year column. So we pass that here, and we're going to use a lambda. Now the trick here is that the year will need to be numeric. You couldn't try to do it as integer because you would have gotten an error, because some of them don't have a year. So we take the year, and we're going to use string operations on it, because if you recall, this column is not yet a date time. So we access str to then be able to use the slice method. We're taking from the 6th index to the 10th, and that gives us the year if it is present in there. And then we're wrapping this in a call to pd.toNumeric. So wherever there is indeed a year, we're going to get it as a float. And if there's no year, then we get a null. So then we're able to create our new column for no year. And that's just taking that newly created, so that's why we have to use the lambda here. We take the year, and then we check if it's null by calling isNA. So we're storing this back in meteorites. So if we take a look now, the years here that are visible are all floats, and the no year column for those cases is false. So to find that data entry error, there are multiple ways that you could have approached it. The way I'm showing you here is just the way that we can see the full data set, but you could have found it if you did something like describe on that column. So here, if I'm just querying for any meteorites that have a year beyond 2021, and you'll notice that there is indeed one meteorite that, according to this data set was found in the year 2101. So unless NASA has mastered time travel, this is not actually correct. And it turns out if you Google this particular meteorite, you will see that it was actually found in 2010. So for the fifth one, to compare summary statistics of the mass column for the meteorites that were found versus observed falling, here we had to use a group by. So we're going to group by that fall column, which makes that distinction between found versus observed falling. Then we access mass and call describe. And now you have two different rows, one for when they're fell and one for when they were found. For the sixth one, to create a pivot table that shows both the number of meteorites and the 95th percentile of meteorite mass for those that were found versus observed falling per year from 1990 to 2000 inclusive. So there was a lot going on in this one. So it's best to break it out bit by bit. The first thing we'll tackle is filtering down the year. So we take our meteorites, we're going to use query, and we're going to filter down to the year between 1990 and 2000. That is by default inclusive, so we don't have to worry about anything else. Then we're going to call pivot table. We want, in this case, you could have flipped the two. So in this case, I'm putting the different values of year in the index and the different values of that fall column in along the columns. The values that I want to aggregate are the mass column. And then now there's a new trick that you had to try out or trying to transfer knowledge from that cross tab and some other examples that we have, where you could take the ag func and you could have actually passed a list in here. So in this case, we're getting the count, but we're also specifying that we want the 95th percentile. Now, since there's no method directly that will give you that 95th percentile, you actually had to create a lambda in this case, and then specify already that, that you wanted the 95th by plugging it in there. Now, this comes with another trick that by using this lambda, the column is now named lambda, which isn't too helpful. So then we follow this with a rename, a call to rename, and we're specifically targeting that lambda and we're renaming it as 95th percentile. And now you can see that the layout below, we have a hierarchical index. We have one set of the two different values for that fall column for count and another set for the 95th percentile. And then for the last one, using the taxis data from the earlier in the section, resample it to an hourly frequency based on the drop-off time, then calculate the total trip distance, fare amount, tolls amount, and tip amount, and finally find the 5 hours with the most tips. So again, there's a lot going on here, but it's best to break it out bit by bit. So the first part we'll tackle is the resampling to an hourly frequency. So we take our data set taxis, we call resample and specify 1 hour, and then we take our columns that we're interested in and we select those out. Then we're calling sum because we want to sum across all of them. And finally, we call n largest, passing in that we want 5 and that we want the largest ones by tip amount. And we get the following result. All right, so section 2 is done, out of the way. That was by far the hardest content we're going to have today. Let me just check if there's any questions. Okay, good, no questions. And we're going to move on to data visualization. So the human brain excels in finding patterns and visual representations of the data, much more so than working with tabular forms that we've been looking at so far. So in this section, we're going to get a taste of plotting, particularly using pandas, as well as a little bit of matplotlib and Seaborn. And we're going to create a couple different, a variety of different visualizations that will help us better understand the data that we're working with. We're going to start with plotting with pandas. So we saw a little taste of this in the previous section, that we can use the plot method to plot with pandas, which is going to be using matplotlib under the hood. So we're going to see a couple examples of how this works. We're going to be using with the TSA traveler throughput data that we cleaned up in the previous section. So we're reading it in the pre-cleaned version. We're parsing our dates already, and we're setting the date as the index. So a reminder, this is what our data set looks like. Next, we're going to use that matplotlib inline magic command, that IPython magic command. This is going to embed static versions of the plots in the notebooks. And now we're ready to take a look. So we're going to take a look at a line plot as our first example. This will be what we had in the previous section, but we're just going to go a little bit more into what's happening here. So in this case, because we read our data in, Pandas now has determined that that year column is actually numeric. So we have to drop it before we do anything, because otherwise we're going to get that in our plot as well. Then this piece up here is pretty much what we had before, with that one exception I was just saying. When we call the plot method, by default, it's going to plot all of our numeric columns using a line plot. So all we have to provide in this case is the title, what we want to put, and that goes, you can't see my mouse, but that goes at the top of the plot. The Y label targets the Y-axis label, and so we're labeling that as travelers. Notice that we're not passing in the X label, because Pandas knows that the date column is our index, and since the index has a name, it puts it as the X-axis label, because it's using the index as our X-axis. And then we're also setting this alpha. This determines the opacity of the lines. So by default, they're at 1, which means we wouldn't be able to see overlapping lines. So we dial this back a little bit here to 0.8 so that we can see the lines overlapping. And then this is the plot that we had before. Also notice that it's returning something here. This is an axes subplot, or a matplotlib axes object. The reason Pandas is returning this to you is because you can continue to modify the plot by using what is returned. This could mean adding additional things to the plot, or plotting, entirely new piece of information on top of it as well. Okay, so now we're going to take a look at bar plots. So the way we access different type of plots with the Pandas plot method is via the kind parameter. So in this case, it's just a matter of switching that kind from the default value of line to something else. And in this case, we're going to use bar. So we're going to make vertical bars to compare the monthly TSA traveler throughput across years, but by month. And then we're going to format this a little further by using that axes object that got returned that we were just looking at. So we need to import a couple of things for this example. The first, we're going to import from the Python standard library, the calendar module. This will help us provide a month abbreviation instead of using a month number. And then we're going to import from matplotlib the ticker module, which helps us format the tick labels along the axes. And now we're ready to create our plot. So we take our travel data. Because we're working monthly, we want to make sure that we're only working with full months of data. So that's what we're selecting out here. We want all of 2019 through the end of April 2021. So we have full data for this data set. Next, we assign to create a new column for the month, because we're going to need it for the pivot table. So here we're pulling it off the index. Since the index is already a date time index, we don't have to do that .dt thing. We just directly access month. Next, we call pivot table. We want unique values of the month in the index, and the unique values of the columns, or unique values of the year to be in the columns. And then we're aggregating the travelers column using the sum. So that should be familiar. And now we call the plot method. This time we have to specify that the kind of plot we want is a bar plot. We're specifying this rot for rotation of 0 degrees, because we don't want our x-axis labels to be rotated 90 degrees. This makes it a little easier to see. We specify a figure size, which is a tuple of inches, so width, height. We specify the y label, y-axis label we saw before, and then the title. So this is returning our axes object, ax. And now we're going to do two things to clean up the way the visual looks. First thing we're going to do is we're going to use month abbreviations on the x-axis. So to do that, we call the set x tick labels. We pass in calendar's month abbreviation, and we're slicing into this from 1 to the end, because there is no month 0. So we just want those from 1 to the end, and that will give us all the months. And now, as you can see on the x-axis below, those are now month abbreviations. And finally, we're going to modify the way the ticks are formatted on the y-axis so that they don't use scientific notation. In this case, we take our axes, we access the y-axis, then we call the set major formatter because these are what are called major ticks. And then we pass in ticker.eng formatter. This is a class in the ticker module, and it knows how to handle numeric values. It will figure out what kind of units it needs to use. Here it determines that millions are appropriate, and so it tacks on that M and it removes any scientific notation. And so there you have it. You can easily compare different years using the bars here. So some other things to keep in mind here. We saw a little bit there, the ticker module, but there's also functionality in there to not only customize the labels that show up on those ticks, but also to change where those ticks are located. So I've linked to the documentation there. Pandas also supports horizontal bars if you use bar H, and then stacked bars as well. So I've linked to a blog post I wrote that shows how to use pivot tables to create a stacked horizontal bar plot. So definitely check that out. And then the plot method, we saw just a few of the parameters that it takes, but it takes many, many more. So definitely check out the documentation there. You'll also notice that the names of those parameters are pretty much most of the time one-to-one correspondence to what you'll need to use if you use matplotlib calls directly, which is nice as a high-level interface, and it helps you kind of learn matplotlib. But sometimes you will need to use matplotlib calls directly, and we'll see an example of that. So we're going to look at plotting distributions next. So as we were discussing before, Pandas is creating that axes object before us, and it's also creating a figure object, which is what contains the axes object. But if we want to do anything more custom as far as layouts, we might want to create these ourselves using matplotlib and then tell Pandas here, plot on this axes object. So that's what we're going to do in this example. The first thing we have to do is import matplotlib.pyplot. We import this module as PLT, and then we're ready to go. So we can create our figure and our axes by calling plt.subplots. This is going to create, without any additional arguments, it will create one figure and one axis. In our case, we're going to create 3 rows of axes and 1 column. This is all going to be inside of a single figure, but this is going to give us a NumPy array of axes. We want all of our subplots to share the same x-axis and the same y-axis so that the values are going to be aligned. And finally, we set our figure size. So now we use zip to iterate over both the unique years that we have in the data and then the axes. So at each iteration, we're going to get one of the years and one of the axes to plot on. So we take our data, we subset it to just the year we're concerned with. Notice that we have to convert this to a string because we don't want the row number 2019. We want the data that is in the year 2019. So that's why we have to do that here. We take the travelers column, and that's going to be the data we're going to plot. So for our first plot, we're going to create a histogram by calling plot, specifying kind equals hist. We're turning the legend off by saying legend equals false. We're specifying that we want this to be plotted with density because we're going to draw a KDE on top, and we want the scales to be the same. We're setting our alpha, which we discussed before, and now we're passing in our axes. We're telling Pandas where it should draw this, and we want it to draw on that axis. Next, we make another call to plot. This time we say the kind is KDE, kernel density estimate. We still don't want a legend, but we want the color to be blue so that they're both the same color. And we're passing in the axes once again. Lastly, we're calling the set method on our axes to set the title and then the y-axis label. So what's neat about this set method is it lets you set all these things at once. But if you notice that title, x-axis label, these are the same things that we were passing into the Pandas plot method. So matplotlib recognizes those. And finally, we're going to handle any overlaps and clean up the way the figure is laid out by calling the tight layout method on the figure. And here you have it. You can see easily the shift in the distributions over time. From 2019, we shifted to the left to 2020, and now it's slightly shifting back in 2021. So Pandas will let you do some level of subplots and layout, but your data has to be structured in a way that it will work for that. So it's very important to understand how to do this in Matplotlib directly. Okay, now we're going to take a look at plotting with Seaborn. So Seaborn provides a higher level interface that builds on top of Matplotlib. There are some additional plot types that are there, but a big advantage of working with Seaborn is that you can also work with long format data. And so here we have the same example that we just built, except because our data is in long format, we can put this together. So we're going to import Seaborn as SNS, that's how you'll typically see it imported. And then we're going to use the dis plot for distribution plot. We're going to pass in our data, which is our data frame. X is what we're plotting the distribution of, so our travelers column. And this is going to give us a histogram by default, but we also want the KDE, so we specify KDE equals true. And we also specify that we should create a new subplot as a column of our layout for each distinct value of year. So that's what we get with col equals year. So you notice that this gives us 3 subplots all next to each other. They're sharing both the X and the Y axis automatically. And they have a nice title at the top that indicates what year it is. And so this is one liner for what we just built up before. So another thing we can do easily with Seaborn is to create a heat map. And a heat map is very helpful in visualizing a pivot table. So that's what we're going to do here. We're going to take our TSA melted holiday travel data. We're going to grab only the full months. So all of the data up to and including April 2021. We're going to add that month column that we had before. We once again create our pivot table with distinct values of the month in the index, distinct values of the year column along the columns, and we're aggregating the travelers column as the sum. So that's pretty much what we had before. That's our data. Now we call sns.heatmap. We're passing in our data, which is that pivot table we just created, divided by 1 million, because we want to be able to show annotations. We're then going to provide a color map, a C map. We're using the blues color map from Matplotlib. We specify annote equals true to show annotations, and the FMT is the format of those annotations. We're going to use 1 digit of precision, and that's so we're going to be able to show what you see in the image. That is going to also return a Matplotlib axis, which we can then use to customize a bit. So because we have the index being the month, we want to name those, instead of using month 1, month 2, be able to show them as their month abbreviations like before. This time we need to do set Y-tick labels, but we're passing in the same thing we had before, the month abbreviation from 1 to the end. Notice that it's called rotation equals 0 and not rot. So that's one difference to keep in mind from Pandas and Matplotlib commands. So that sets the Y-tick labels. Then we have to set the title. And to do that, we just call set title. We pass in title, and now we have what you can see here. Now, a neat thing to notice is that on the colors that are lighter, Seaborn has already determined for us that it should be using black text. But on the colors that are darker, Seaborn notices that it should be using white text so that we can actually see it. That's something we would have had to code up the logic for ourselves if we were not using Seaborn. All right, so that was a quick taste of Seaborn. I've linked to the API for more information. Also suggesting some plots to take a look at here. So pairwise plots, some plots for visualizing categorical data on one axis and numeric data on another, which are swarm plots, as well as plots for joint distributions, and the facet grid, which was underlying visual that was part of the distribution that we looked at previously. And now we're going to look at how to customize the plots with Matplotlib. So obviously, there's a lot of functionality available in Matplotlib if all these libraries are building on top of it. But we're just going to see that just a couple of things you can do to highlight specific areas of plot and provide annotations. But I've linked to the documentation for more. So let's take a look at adding shaded regions. So we're able to plot our TSA traveler throughput over time, but we went through all that trouble of showing where the holidays are. So it's nice to be able to show that information on the plot as well. And we're going to do that with shaded regions. So for this example, we're going to just take a subset of the holiday travel. In this case, it's from May 2019 through November 2019. We get the travelers column and we call plot. And then we're also specifying the eng formatter on the y-axis. And so now we have to create those shaded regions. The first thing we have to do is figure out when those regions start and end. And that's what we're doing here. So we take the plot data, we're dropping any null values. This will get rid of any dates that aren't related to any holiday. Then we're resetting the index because we need the dates that are in the index to aggregate. Then we're going to group by holiday. And for each holiday, we're going to use an aggregation on the date column to find the minimum date and the maximum date. So that would be the start and end of the holiday. So that's stored in holiday ranges. And then we're going to just extract this as a NumPy array so we can work with it easy. And we're going to shade those regions. So for each iteration across this NumPy array, we get the start date and the end date of the holiday. And we're going to use plt.axvspan to specify the start and the end. And we're going to color this region gray and use an alpha of 0.2. So it has a very low opacity. So it's very transparent. And so you can see now those gray bars that are shaded, indicating when holidays are there. So there's also AXH span for horizontally shaded regions, and AXV line and AXH line for doing just reference lines rather than full regions. And likewise, there's also, rather than using the PLT directly, you can use it on the axes object. So last thing we'll cover here is annotations. So you can use the plt.annotate function to add annotation text to your plots. In this example, we're going to annotate the day in 2019 with the highest traveler throughput, which we saw already was the day after Thanksgiving. So we take our data and we're filtering down to just 2019. Then we're going to plot the travelers column as we had before and use the engineering format for the y-axis labels. This is the piece we have new here, the highest throughput. So we take our plot data, access the travelers column, and we're using IDX max to get the index of the maximum. Because our index has dates, that's why we need IDX max and not something like argmax. So this is our max throughput date. And we also need the max value. So we take the max to get that max throughput. Then we call the annotate function here. The first argument is the actual annotation we want to place. So in this case, we're placing the date formatted as month abbreviation space day number. Then we have a new line. And then we have the throughput in millions, in which we're formatting with 2 digits of precision. And then we're tacking on the M at the end. This piece is in parentheses. And then we have our XY argument, which is a pair of coordinates that we are, for the point that we are annotating. So this is the max date is the X and the max throughput is the Y. Now we don't want to put our annotation, in this case, exactly on that point. We're going to move it slightly to the side. So that's what we have with XY text. We're specifying, in this case, the coordinates of where the annotation text is going to be. So as you can see below, it's off down and to the left. And so we're taking where the date actually is, and we're moving to the left by 23 days, and we are moving slightly down from the maximum throughput. And finally, we have arrow props, which we're giving it a dictionary of a style to use for the arrow, because we want to point from our text to that maximum value. And then we're also specifying horizontal alignment, HA, of center, so that our text, which has 2 lines, is centered nicely. And you can see that text now in the plot with the arrow pointing to that peak on November 29th. Okay, so we saw some variety in how you could work with these plots. We saw some cases where we were using PLT functions, and others when we use the axes object directly. For most cases, it's named the same, but in sometimes you'll need to say for the axes set underscore and then whatever you're targeting. Either can be used. And it's important to note that sometimes when you use the PLT functions, you might be thinking that you're targeting a specific axis, but you're actually only going to target the last axis that was created, the current one. To target specific ones, always it's better to use the commands on the axes themselves. Okay, so I'm also linking here to a new workshop I just created. I actually delivered it for the first time yesterday. It has information on a little bit more of a deep dive into matplotlib, working with it directly, creating a variety of plots, as well as how to do animations and interactive plots. So definitely check that out as a next step. And with that, we're going to move on to our lab next, but we'll take a little bit of a break to do some exercises. And I'll be in the chat if you have any questions. Finishing up 3, impressive. All right, well, let's move on. So we have time, a little bit of time for the lab. But if you're curious, if you want more of these exercises, you can check out that other workshop as well, which has more visualization workshop exercises. As far as a rule of thumb for when to copy a data frame, so subsequent changes do not impact the original data frame. I would say, I think if I'm understanding your question correctly, I would say anytime you're building, especially if you're building a function, then you should always be copying it inside so you don't have unintended consequences. I'm not sure if I'm fully understanding the question there. The other way you might get an error, or that you're saying an interpreter warning, it could actually be if you're not using lock and iLock, and it will complain about setting a value on a copy. So I'm not sure, Ryan, where that question comes from, but feel free to clarify more in the chat, and I can answer when we get started with the lab. I'm not sure if this is when you would get to access the recording, but it is being recorded as well. So, okay, so let's go over these exercises. So for the first one, create box plots of TSA traveler throughput for each year in the data. So start by taking our data frame, and then we had to pivot it. Here, we're putting the unique values of the year in the columns, and then the total travelers as the values. So we actually don't need to specify the index in this example. Then we take our plot data and we call the plot method, which passing kind equals box to get a box plot. This returns a matplotlib axes object, which we can then call the set method on to set the x-axis label, the y-axis label, and the title. And finally, here we're taking the y-axis and setting that major formatter to use that eng formatter from ticker so that they show up in millions. And you notice it actually has 500K down there. For the next example, using Seaborn, create a heat map that shows the 2019 TSA median traveler throughput by day of week and month. So first off, we had to create our pivot table. We take our data, select just the 2019 values, then we call assign, creating a column for the day of week, which we pull off the index using day of week without any underscores. We also pull off the month. Then we create a pivot table. You could have flipped the index and the columns here, but here I have the index as distinct values of day of week and the columns as distinct values of month. Then I'm aggregating the travelers, but now I'm using median as the ag func instead of mean or some other aggregation. Next, using sns.heatmap, passing in the data after dividing by 1,000,000, turning on annotations. We want 1 digit of precision in the annotations. We're using that same color map, the blues color map. This returns our axes object, which we then call set xtick labels. And here's the trick for month abbreviations that we've seen before using calendar. So we go from 1 to the end. For the y-tick labels, which I have my day of week on, the trick here is to use day abbrev from the calendar module. And here, the day 0 is valid. So we don't have to worry about doing that special trick from 1 to the end. So with that, we have our day abbreviations, and we set the rotation to 0, just so they're not turned sideways on the y-axis. And finally, setting the title. And for the last one, to annotate the medians in the box plot from the first exercise. So here, the top 4 lines are what we had from before, and the rest is the new stuff. So for adding the annotations, we first need to calculate the median for each of those years. So we take our plot data, which has a column for each year, and call median. So now this is a series where it has an index of the year and a value of the median for that year. Then we take our xtick labels, which are going to have the years on them if you take a look at the plot. And for each of those xtick labels, we're going to index into the medians and grab that year's median. So we can get the text off of the tick label. We have to convert it back into an integer because we're using integers in our years are integers in this case, and that's how we need to index that series. So this gives us the median for that particular year. Then we can call annotate on that axis, and we pass in our annotation, which is going to be the median divided by 1,000,000. And then we're going to use 1 digit of precision and add on that m for units at the end. We specify our xy as where we're going to place it, where we're annotating. So we take the position, which is going to give the xy coordinates of that label. We only care about the x in this case because our y is going to be the median. So we take the first coordinate. Then we have HA for horizontal alignment of center. We're centering it within the box plot. And then we have VA for vertical alignment. We're placing it bottom, which will have it effectively sitting on top of the median line, as you can see below. All right, and with that, section 3 is done, and we're ready to move on to our lab. So this is an opportunity for you to practice everything we've learned so far. There's going to be a set of questions that are in that Google form linked there. So if you open the 4th notebook, you should have a link to it. I haven't opened up the form yet, but I will when I just say my little spiel here. You can submit to that form and it will tell you what you got wrong, if anything. You don't have to fill out everything in order to submit. And there are definitely going to be more questions than you have time to answer. We will not be going over the solutions to these, but this is a chance for you to try on your own. If you do want more practice, there's also an asynchronous lab folder in the repo with answers for more for a different set of practice questions. Okay. Yeah. So with that, let me open the lab. Okay. So the lab should be open now. I will also post that link in the Zoom if you're not able to access it. So someone let me know if they're able to access the lab. Yes, the form. Are you able to see the questions? Perfect. Okay, so you can work through those questions. The data is also provided in the repository that we've been working with. So yeah, get started and let me know if you have any questions. I also have 10 copies of my book to give out. So if you're interested in one of those, you can send me a private message in the Zoom and I will pick randomly. No, the asynchronous lab is actually different. So it has an entirely different set of questions. So I would recommend that you do the form now, because when this session is over, the form will be closed and you only have the asynchronous one. And if you're interested in the book, please send an email address so I can contact you. I'm also going to drop in the chat a discount code that you can use if you don't happen to be picked as a winner. How long is the form going to be up? I can maybe leave it up through the end of the day, but I don't want to leave it up permanently because then there's no, hidden content. But the asynchronous lab will permanently be there. It's part of the repository and it's free for you to use at any time. So it's additional work. All right, everyone, we're coming up on time. So I'm just going to say a parting speech. Thank you all for your time. I enjoyed giving the course and I hope you all enjoyed working through the exercises with me. I encourage you to check out my Beyond the Basics Data Visualization in Python workshop if you want to get a little more experience with data viz in Python. And then also check out my book for more Pandas examples, as well as visualization and a little bit of scikit-learn. I put in the chat a coupon code for 25% off if you're interested. And also send me a private message with your email if you want to be entered to win a free copy. Thank you so much for your time, and I hope you enjoy the rest of the conference. I will leave the lab open for the rest of the day as well if you're interested.